Okay, let's continue this video because this didn't really explain all the nooks and crannies of this lab, because if this was how simple it was, you guys would have got it lickety split. You guys know how to make a data table with an independent variable and a dependent variable, what you change, what you measure. You guys know how to do this. But the nitty-gritty details, that's probably what made this lab a lot more tricky. So one of the things that was tricky about it was our dependent variable. How did we measure acceleration? How do we measure acceleration? Here's our dependent variable. Well, we used those motion sensors. We used that Logger Pro software. What that did was it created a velocity versus time graph. Remember, velocity is measured in meters per second. That's our units for the variable velocity. And the variable time, the units are seconds. So this is where a lot of people got held up. So how did we measure acceleration? Well, we used the slope of a velocity versus time graph that was created using that motion sensor. Once that cart started to take off, it created a graph. Graph might have, it had a red line usually, and it had maybe a little spike, and then something happened right there. Kind of made a little shape like this. Most people look at this and they go, hey man, I don't know what the heck's going on. But you guys know that this is graphing velocity on the y-axis, time on the x-axis. So if you look at, right here at 2 seconds, it's got a certain velocity. Maybe the velocity is, 0.1 meters per second. And over here, at 3 seconds, the velocity was 0.2 meters per second. So at this point in time, the velocity, maybe I need to zoom in on that. At that point in time, the velocity is changing. Velocity is changing. And remember that acceleration, that's the rate at which the velocity, I'm going to go like this. It's the rate at which the velocity changes. You might not have seen this yet, but velocity divided by time, that's what acceleration is. So let's take a look at this graph. If the velocity is changing, this slope right here, that slope, you might have used a little button that looked like that and had a little line on it, and you kind of followed it around. You saw right here, oh, the slope's totally flat. Whoa, the slope's really steep over here. But right here, this is what you wanted to capture. And you got a little text box that popped up when you did that. And it said, slope equals, 0.1 meters per second per second. That's what that slope is measuring. That's what that slope is measuring right there. That spot where the velocity is increasing at a constant rate. That's how we measured our acceleration. Pretty complicated using all that software. So if you were to be asked, how did we measure acceleration? The answer, we looked at the slope. We looked at the slope of a velocity versus time graph on that Logger Pro software that we set up with the motion sensor. So by looking at the slope of a velocity versus time graph, we were able to measure the rate at which the velocity changes. We were measuring the rate at which the velocity changes. So remember, if you're increasing velocity, which is what we're doing here, that means that you are speeding up. Speeding up. And remember, speeding up, well, that's the same thing as accelerating. That's the same thing as accelerating. If you're increasing your velocity, that means you're going from a slower velocity, right here it's 0.1 meters per second. You're increasing your velocity here to 0.2 meters per second. And if you increase your velocity, that's your acceleration. That's your speeding up. Okay, I'm gonna ask you some questions about that.